9 things the ancient Maya built that our best laboratories still cannot fully reproduce. A pigment that laughs at acid, a rubber recipe thousands of years ahead of its time, a cement that heals itself, and a staircase that answers you back when you clap. Some of these technologies were rediscovered only in the last 5 years, and one of them is hiding something we have not figured out yet. Every fact comes from peer-reviewed research published between 2008 and 2025, and where the experts disagree, I will tell you. Maya blue. Maya blue is a pigment made from indigo combined with a fibrous clay mineral called palygorskite, then heated until the two bond together. From roughly 300 BCE through the colonial period, it coated murals at Bonampak, decorated pottery at Chichen Itza, and colored the bodies of sacrificial victims. Concentrated nitric and hydrochloric acids cannot break it down, neither can organic solvents, and more than 1,000 years of tropical humidity and ultraviolet light have failed to fade it. The pigment's extraordinary durability has puzzled modern scientists. The modern investigation begins with Edward Thompson, who dredged the sacred cenote at Chichen Itza between 1904 and 1911 and pulled up a layer of blue sediment 4.5 to 5 meters thick, a figure documented in Dean Arnold's 2008 paper in the journal Antiquity, produced with researchers from the Field Museum in Chicago. In 2024 and 2025, Arnold reported a second production method using wet ground clay and indigo plant material cooked together in small tripod bowls. The Maya kept more than one recipe. Vulcanized rubber, thousands of years before Goodyear. Charles Goodyear discovered vulcanization in 1839 and received his patent in 1844. The Maya and their Olmec predecessors were doing something similar around 1600 BCE. At El Manati, an Olmec bog in Veracruz, Mexico, archaeologists from Mexico's National Institute of Anthropology and History pulled 14 solid rubber balls from the mud, some weighing nearly 5 kilograms. In 1999, an MIT team led by Dorothy Hostler published in the journal Science, showing that Mesoamericans harvested latex from the Castilla elastica tree and cross-linked it with juice from a morning glory vine called Ipomoea alba. A 50-50 mix delivered maximum elasticity for ballgame balls, while roughly 75% latex to 25% morning glory juice produced maximum wear resistance for sandal soles. Aztec tribute records document 16,000 rubber balls per year flowing into Tenochtitlan as tax payment. A 2023 study on the El Manati balls could not detect any Ipomoea residue, which means either the molecules have broken down across 36 centuries or the earliest Olmec recipe was something different. The oldest water filter in the Americas. On October 22, 2020, a University of Cincinnati team led by Kenneth Tankersley published in Scientific Reports what they found at the Corriental Reservoir in Tikal, Guatemala. The system was a water filter built from zeolite, specifically the minerals clinoptilolite and mordanite, combined with coarse quartz crystals. It operated roughly from 185 BCE to 1055 CE. The materials came from a volcanic outcrop called Bajo de Azucar, about 30 kilometers northeast of the city, where water emerged unusually clean. Tankersley put it this way: what's interesting is this system would still be effective today, and the Maya discovered it more than 2,000 years ago. Nothing older has been documented in the Western Hemisphere. Pressurized water at Palenque. In 2010, Penn State researchers Kirk French and Christopher Duffy published in the Journal of Archaeological Science a paper describing a stone conduit at Palenque in Chiapas, Mexico, known as the Piedras Bolas Aqueduct. The channel stretches at least 66 meters along a steep slope, and near the outlet, the passage abruptly narrows to a square opening roughly 20 centimeters on each side. That geometry could generate a theoretical hydraulic head of 6 meters, or roughly 20 feet of water pressure. Duffy commented that under natural conditions, it would have been difficult for the Maya to see examples of water pressure in their world. He said they were apparently using engineering without knowing the tools around it. What the pressurized water actually powered remains unknown. since the terminal end of the conduit has collapsed and has never been excavated. A self-improving cement. Classic Maya plaster holds together for more than 1,000 years in humid jungle conditions. In 2023, a team led by Carlos Rodriguez Navarro at the University of Granada published a paper in Science Advances explaining the trick. Working with samples from Copan in Honduras, including the late 6th century Rosalila temple, they discovered that the Maya added extracts from tree bark, specifically chucum and geode, to their lime plaster. Those organic compounds transformed how the cement crystallized, with calcite forming through an amorphous precursor phase and producing nanometer-scale grains bound together in a structure that closely resembles a seashell. The result was a plaster with greater flexibility, stronger resistance to dissolution, and the ability to self-heal against minor damage. Bishop Diego de Landa had already described it in the 16th century, writing about a local mortar strengthened with some sort of water coming from a tree bark. The LiDAR revelation. On September 28, 2018, the journal Science published a paper that rewrote Maya archaeology in an afternoon. The PACUNAM LiDAR initiative used airborne laser scanning across 2,144 square kilometers of the Maya Biosphere Reserve in northern Guatemala, stripping away the forest canopy digitally. The result was 61,480 previously unknown structures, including roads, reservoirs, farms, terraces, fortifications, and entire cities. Population estimates for the central Maya lowlands at their late classic peak were revised upward to between 7 and 11 million people. Marcello Canuto of Tulane University put it this way: "This was a civilization that was literally moving mountains. We've had this Western conceit that complex civilizations can't flourish in the tropics, that the tropics are where civilizations go to die." In 2024, a Tulane graduate student identified an entire lost city in the Mexican state of Campeche, now called Valeriana. Astronomy, accurate to minutes. The Dresden Codex is one of only 4 surviving Maya books, and 2 of its tables qualify as astronomical masterpieces. The Venus table tracks the 584-day cycle of the planet with striking precision, since the true modern value is 583.92 days. The eclipse table spans 405 lunar cycles, which works out to 11,960 days, and the modern value for 405 lunations is 11,959.89 days. The Maya figure is off by about 1/10 of a day, or roughly 7 minutes per lunation, averaged across nearly 33 years. In October 2025, John Justison and Justin Lowry published in Science Advances, arguing that the Maya sustained this accuracy across more than 700 years by using overlapping reset cycles. On September 30th, 2018, Mexico's National Institute of Anthropology and History formally authenticated the Maya Codex of Mexico, radiocarbon dated between 1021 and 1154 CE, which makes it the oldest surviving book of the Americas, roughly 200 years older than the Dresden Codex. Buildings that tracked the sky. At Chichen Itza, the round tower known as El Caracol has a grand staircase pointing 27.5 degrees north of west, matching the northernmost setting point of Venus. Anthony Aveni and colleagues published that alignment in the journal Science in June 1975. Slovenian archaeo-astronomer Ivan Sprajic and his colleagues later measured 271 orientations at 87 Maya sites, finding that most track sunrise or sunset on dates separated by intervals of 13 and 20 days, the core building blocks of the Maya ritual calendar, while a smaller group targets the extreme positions of Venus. Here is where the consensus has quietly shifted. The popular idea that the Maya built temples to mark the spring and fall equinoxes has turned out, according to Sprajic's 2021 analysis, to be largely a modern interpretation rather than a documented Maya practice. Solstices and Venus extremes carry the weight of the evidence. The sound of the Quetzal. Clap your hands in front of the main staircase of El Castillo at Chichen Itza, and what comes back is a strange chirped echo, a descending sweep of sound. David Lubman reported it in the Journal of the Acoustical Society of America in 1998. In 2004, Belgian researcher Nico de Klerk and his colleagues published a formal analysis in the same journal, modeling the staircase as an acoustic diffraction grating. In 2006, a measurement captured the chirp as a pitch sliding from 796 Hz down to 471 Hz within 177 milliseconds. The Great Ball Court, dedicated in 1142 CE, carries its own oddity, which is that a whisper at one end carries roughly 140 meters to the other. Lubman argues the staircase was tuned to imitate the call of the resplendent Quetzal, the sacred bird whose name is embedded in Kukulkan, the feathered serpent. De Klerk, initially open to the idea, has grown more skeptical, pointing out that similar effects turn up at unrelated staircases. So, there you have it. 9. Maya technologies that modern science has studied, measured, and, in several cases, is still working to fully explain. All of it built without metal tools, without the wheel for transport, and without draft animals. That is not a mystery of impossibility. It is a mystery of how thoroughly a civilization can be underestimated